Are you ready to learn one of the most exciting subjects of all time? Are you prepared to witness the power and awesomeness of
Okay, so you may not be as excited about chemistry as I was right now. I understand that you're tired because of all the work that needs to be done. Don't worry. My colleagues and I, Christian, aka the Cuban, and PDG, aka Nick, will try to make this short and simple so you can go back to procrastinating all the work that you have. Deal?
What are we going to teach you is how to set up and solve equilibrium equations. Got that down? Okay, now as scary as they sound, they're actually pretty easy. The best thing about equilibrium expressions is that it's algebra. That's it. Like in algebra, all you have to do is find out the equation, plug in the numbers, and solve for x. That may seem difficult to some, but trust me, it's easier than you think. To give some better understanding, I'm going to let Nick explain. Good luck with that.
Alright guys, here's the first example. Now what we are going to do is first explain how you set up the expression. You see this G symbol? This means that this is a gas. You can only use gas and AQ symbols in equilibrium expressions. If there is a symbol other than this, you won't need this part to make the expression. Lucky for us, we don't need to worry about that part of this expression. For expressions to work, you need to know that the equation for setting up these expressions is K equals product over reactant. So that means since 2NH3 is the product, the expression will be written as K equals NH3 squared. If you're wondering why the squared, no, not that squared, it's because the coefficient always becomes the exponent. Whatever number is in front of the element always becomes the exponent in the expression. Now that we talked about the product, let's talk about the reactants. You write it under the product because it's a reactant. So now it's going to be K equals NH3 squared over N2 times H2 cubed. Because the coefficient is 3 in 3H2, the element is cubed. That's it. That's how you set up equilibrium expressions. Alright, see? That wasn't so bad. To make sure this stays in your brain, because a few of you probably weren't paying attention. You know who you are, hopefully. We'll do a few more.
So this is the next example, as you can obviously see. What you should also see is that they're all gases, so it's going to be easy. So how would we write this? That's right, you probably didn't even answer, but I'm fine with it, kinda. So what we do is look at the products. Since there is two elements, we're going to put the two next to each other, so we can multiply them. So we should write like this. K is equal to H2 times CO2 over. Now since these two are the reactants and gases, they'll go underneath the products. So now you should have K equals H2 times CO2 over H2O times CO. Awesome. Now you're getting it. At least I hope.
Alright, now we are going to do the math portion of this lesson. I know, right? Fun! Alright then. So we just learned how to set up equilibrium expressions. If you didn't, then you should have paid attention. But don't worry though, because we're still going to go over it during this example. This is the example we're working with. And as you can see, these are all gases. What you have to remember is to always make sure that your equation is balanced. If you try to solve for K or any missing value, you will not get the right answer if it's not balanced. Now the info we have for this is that K equals 10.5, the concentration of hydrogen is 0.933 m, and the concentration of methanol is 1.32 m, meaning we have to find out what is CO. Now we have to make sure that this equation is balanced. To balance this, you put a 2 in front of H2 because there will now be 4 hydrogens on this side and 4 hydrogens on this side. Everything else is set up fine, so we're done with balancing. Next is setting up this expression. Since we know that the expression is K equals products over reactants, we can easily plug in our elements because they are all gases. If one of the elements wasn't a gas or aqueous, we wouldn't use it. Just plain out, we wouldn't use it. What we should have is K equals CH3OH over CO2 times H2 squared. It's squared because 2 was the coefficient. Since we have set up this expression, we're going to do something new-ish. We are going to plug in the numbers of the moles of the elements. So we're going to put 1.32 in the spot where the products belong because that's the moles of CH3OH, according to the information we were given. Same thing goes for hydrogen. So we plug in 0.933 in place of hydrogen. Now we have to find out what's CO. Since hydrogen is being squared, we have to square 0.933. If we do that, 0.933 becomes 0.87. Still alive there? We only have a few more steps, so don't fall asleep yet. Now what we have is 10.5 equals 1.32 over x times 0.87. Since x is on the denominator, we have to multiply x on both sides. So x cancels out here, and 10.5 becomes 10.5x. Now we divide 1.32 by 87, which gives you 1.5. Next, we get the x by itself. So we divide 10.5 on both sides to get our answer. These cancels out, and we divide 1.5 by 10.5, and we get 0.14. So our answer is x equals 0.14. Wow, that was a lot of words and information. We're going to give one last example and we're done.
You still alive? Well, we're gonna do our last example. So in this example, all of these are gases, so it's gonna be pretty easy. Remember that the K products are over the reactants. So we're going to write K is equal to SO3 squared over SO2 squared times O2. If you have any questions, please let us know. Now that we set up our equation, it's time to solve it. Our information that we have is the moles of SO2 is 5, the moles of SO3 is 4.5, and the moles of O2 is 2.7. With that being said, we need to solve for K. We use our information and plug it into our expression. What we should have now is K is equal to 4.5 squared over 5 times 2.7. First, we worry about the expressions, so we square these two numbers. 4.5 becomes 20.25, and 5 becomes 25. Now we multiply the denominators first to get one number. We then get 67.5. The last step is to divide 20.25 by 67.5. We then get 0.3, so x is equal to 0.3. That's it. We are done for this lesson. If you have any questions or want to see this video again, you can see it at channel name BoneBracker43.
Hope you enjoyed this video and learned something at the same time. This video was fun to make and edit, so I hope you understand a little better on how to set up and solve equilibrium expressions. Thank you for watching, and I hoped you learned something.